These are the notes on solving quadratics with the quadratic formula. I have your steps listed up here. First thing is make sure you're in standard form, and that means that ax squared plus bx plus c equals 0. Everything needs to be on one side of the equal sign. Next thing is to pull out all the values. Pull out the value for a, the value for b, and the value for c. Plug them into your formula, substitute, and then do your order of operations, and then simplify if you need to. I'm starting with a basic example so you get the concept down. I'm going to review this by factoring so that you can see how the formula works. So the first thing is I need two numbers that multiply to give me 5, and they are going to also add to give me -6. I know that it is going to be -5 times -1, because -5 plus -1 gives me -6. Zero product property says that x is +5 and x is +1. I think if you have a straightforward example, that's straightforward and you can factor it, rock and roll and factor. This is just to prove how these two answers will be the same regardless of however you attack this problem. So the first thing I check is to make sure I'm in standard form, which I am because I am set equal to 0. So my a value is +1. My b value is the -6. And my c value is the +5. I'm going to plug this into my formula up here. This is going to be a very extenuous example because I'm going to write this example out step by step, and then the next 3 examples are we're going to skip steps, so it's not going to be as exhaustive as this one. So I'm going to begin by substituting. X equals the opposite of b plus or minus my b squared minus 4 times a times c, which is 5, all over 2 times a. And there's a reason I'm putting 2 times a in red. The 2 times a is consistent. It will always be 2 times a, but when I start skipping steps, I'm just going to do this at one time. So the first step is to make sure that you substitute properly. Now I'm going to make little notes as I go through each step. So the second step is to actually take the opposite of b. My b is a -6. I'm going to negate that, and it is going to create a +6. After this example, I'm going to start putting it in as the opposite sign. Plus or minus. I'm going to go ahead and square -6. This b squared value will always be positive. Minus 4 times a times c all over 2a. So in this step, I negated -6 and it became a +6. That was the first thing I did. The second thing I did was -6 squared gave me a +36, and the last step I did was 2 times my a gives me my 2. So I did some simplification in this step right here. All right, I'm going to simplify some more. X equals my +6 plus or minus square root of my b squared minus 4 times 1 is 4 times 5 is 20 all over 2 times a. All right, so in this step I said 4 times 1 times 5 is where I got the 20 from. and I'm going to continue simplifying. 6 plus or minus the square root of 16 over 2. So these values are not changing. The 6 follows all the way down. The 2 follows all the way down. In this step, I did my 36 minus 20, and that's where I got my 16. At this point, I can take the square root of 16, and I get 6 plus or minus 4 over 2. Square root of 16 is where I got my 4. And this is what I mean by step 5 to simplify. I have 6 plus or minus 4, so I have 2 answers in this fraction right here. I have x equals 6 plus my 4 divided by 2. And I also have x equals 6 minus my 4 divided by 2. So at this step, I'm going to break it up into my 2 solutions. My plus solution and my minus solution. So I have my 6 plus 4 over 2 and 6 minus 4 over 2. I'm going to simplify this. 6 plus 4 is 10 over my 2. I'm going to keep that in red. The 2 stays the same. Equals 5. That is 6 minus 4, which is 2, over my 2 is equal to 1. I'm going to split up the fractions and reduce. And my answers are x equals 5 and x equals 1, just like they're supposed to. So the next 3 examples will not be this large. This is just one example that has all the pieces broken down. At this point, I'm going to start skipping steps, so I at least wanted you to have one very, very broken down step-by-step example. So